All right, hi everybody. So sorry that I am not with you today. I will see you on Monday. But going over number 3, hopefully you have all tried this, yes, in your groups and or with those sitting around you. Remember that we always want to take the first term and divide it by the first term. So first thing I'm going to do for this one, and it doesn't matter that we have this crazy long polynomial divided by a quadratic trinomial. It might matter to you. You might be annoyed because it's more work. So my apologies. So I'm going to take 4x to the 6th and divide it by x squared. And I talked about this with a few of you on Wednesday. You don't have to write it out like this. I do because it helps me to see what's reducing. And so I get 4x to the 4th. So that's going to go up here. And then we multiply through. So 4x to the 4th times x squared gives us 4x to the 6th. Remember, oh dear, okay. Remember that when we multiply variables that are the same bases, we add their exponents. So 4 plus 2 gives us 6. And then we get plus 4x to the 5th, and then plus 8x to the 4th. Now, next thing we do in long division is change the signs. We subtract, so I'm going to change the signs. Then these cancel out. 0 minus 4 gives us negative 4x to the 5th. Negative 12 minus 8 gives us negative 20x to the 4th. And then we bring down our next term, even though it's a 0. We still have to bring it down as that placeholder. Okay, so then the next thing that we're going to do is we're going to divide negative 4x to the 5th by x squared. So I'm just going to write it over here. Again, you don't have to, just my personal preference, so that I can see, oh, okay, I have negative 4, and then the x is reduced to x to the 3rd. So that's going to go up top over here, so minus 4x to the 3rd. Hopefully the colors are helping you follow along. And then we have negative 4x to the 3rd times the first term that we're dividing by, x squared. So we get negative 4x to the 5th. Multiply it by that second term, so negative 4x cubed plus x, we get negative 4x to the 4th minus 8x to the 3rd. Yay! All right, subtract, change the signs. The first terms will cancel. Negative 20x to the 4th plus 4x to the 4th gives us negative 16x to the 4th. We get plus 8x cubed out here, and then we bring down the negative 24x squared. All right, let's keep going, my friends. So we take negative 16x to the 4th divided by the first term only. And I'm going to write it over here as I've done the previous 2 times. Again, you don't have to. I know you're thinking, yeah, you've said that before. But the more I say it, the more hopefully it'll stick. So we get negative 16x squared. I'm going to put that up at the top like we did the other 2. And let's multiply. Negative 16x squared times x squared gives us negative 16x to the 4th. Again, when you multiply the same variables, the same bases, you add their exponents, and then we get negative 16x cubed minus 32x squared. Almost there, my friends, almost there. We're going to change the signs. Why? Because we're subtracting. So the first terms cancel. We get 24x cubed plus, what is that? 8x squared. Yeah, math in the morning. Okay, plus 0x. I know that's what y'all are thinking too. See if I can move that. There we go. All right, last but not least, I believe, we'll see. We're going to take this term and divide it by the first term. I'm going to go a little bit faster because, again, this should be done on your papers already. I'm just going through it in case there's any confusion or any questions you were unable to answer as a class, as a group. So we're left with 24x. That goes up top. And we multiply through. So 24x times x squared gives us 24x cubed plus 24x squared plus 48x. And then what do? Yep, we are going to subtract change the signs. Now, hopefully you've noticed when we get to this part in long division, this first set of terms should always cancel out. That's if you did your division properly, okay? So it's a nice little self-check. If they don't cancel out, retro, go back, figure out what happened. Oh, I was wrong. We've got one more to go. Let's go back to orange. So I'm going to take this first term and again divide it by this first term. All right, and we've got negative 16x squared divided by x squared. What does that give us? Woo, negative 16. Okay, so we have negative 16 on the outside. We're going to multiply through. That gives us negative 16x squared minus 16x minus 32. Oh my, this is interesting. Why? It's not interesting, Patterson. It sure is. Okay, so we cancel out those first terms. We get, negative 32x plus 0. What is this? Yep, this is our remainder. So we're going to write minus 32x over our divisor, which is x squared plus x plus 2. Whew, okay, how many of us got this correct? Small mistakes, no mistakes, lots of mistakes? It's definitely at this point that you want to go back to the previous two with your group, figure out where the mistakes are being made, if any, and try to fix them for this, okay? Now, think about if there is a remainder, what does that mean? Yes, it means that there is not a factor, okay? There is not, or the divisor, pardon me, is not a factor. That's what we use long division for, to prove whether it is a factor of the longer, bigger polynomial. If it is, we can build off of that and find the additional factors. So fascinating. You're welcome. Okay, so I'm going to travel into task 4 with y'all. Task 4 continued, because what we were doing on Wednesday, that long division, that is task 4. And I'm going to tell you that we have this function. So y'all, I would recommend writing this down somewhere in your notes on a piece of paper. We have x cubed plus 5x squared minus 2x minus 24. And I'm going to tell you right off the bat that x plus 3 is a factor. Okay, x plus 3 is a factor. Well, think about if we were to graph this, right? X plus 3 is a factor, which means that it is an x-intercept, but where is the x-intercept? We would solve it. So x plus 3 equals negative 3. Negative 3 is an x-intercept. It's a root. It's a 0. Okay, all of these terms we need to be familiar with. Don't judge my z's. Okay, so if I tell you we have this cubic function and x plus 3 is a factor, find the rest of the roots of the factors. What we would need to do is take x plus 3 and divide it out, because we already know it's a factor. We want to know what the other factors are. Okay, here we go. So I'm going to take x cubed and divide it by x. Just to stay consistent with what I've already been doing, I'm going to put it over to the side. Again, you don't have to. We get x squared. So x squared goes up top, and then we multiply through. We get x cubed plus 3x squared. What do we do now? Subtract. Change the signs. Our first terms should cancel out, and they do. And we get 2x squared, bring down the next, minus 2x. And then I'm going to start my pattern over again. Remember, long division is just cyclical. So I'm going to take 2x squared and divide it by x, leaving me with 2x. That goes up top. And then I multiply through. So 2x times x gives us 2x squared plus 5x. We change the signs. Hopefully this is becoming a pretty rote, we'll say, process for you just by memory. You're like, oh yeah, now I changed the signs. So we get negative 7x, bring down the negative 24. Okay, we were told x plus 3 is a factor. So our hope is this next go around that it divides evenly, that we don't have a remainder. We're going to take negative 7x, divide it by x, we get negative 7. Okay, so that's going to go up top. Here we go. Multiplying through, we get negative 7x. What is that? Minus 21. Oh dear. This does not look like it is a factor. So let's keep going, right? These cancel. We get negative 3. So is this a factor? It doesn't look like it. And remember, at the beginning, I told you it was. So this is a great opportunity for us to go back and check. And this is going to happen, and you might get frustrated, especially with the longer long division problems. But let's go back, shall we? Okay, so we've got x cubed divided by x is x squared. When we multiply through, x cubed, 3x, we change the signs, and we got 2x brought down the negative 2. Okay, first round looks good. Then we took 2x squared, divided it by x. We get 2x, that's okay. We get 2x squared there it is. Really? Is 2x times 3 5x? No! Be careful when you're doing these that you multiply and not add. It's an incredibly common mistake. Okay, we found it. We can keep going. See, it's nice when we tell you that it's a factor because then you can self-check. So then we get negative 8x minus 24. Okay, here we go. We're going to take negative 8x and divide it by x. Divided by what? What is happening? So we get minus 8. Losing my mind. So we get negative 8x minus 24. We change the signs. All right, my friends, that should be black. We get 0. Yay! So if we divide it out, we end up with x plus 3 times x squared plus 2x minus 8. If you're unsure of your arithmetic, you can go back and multiply these together. Distribute the x into the trinomial, distribute the 3, and then you should end up at the cubic that you started with. Okay, super nice self-check. I'm sure a lot of you are like, yeah, I know. Okay, but our goal is to find all of the factors, all of the roots. So I'm not completely factored, you guys. We've got this quadratic trinomial. There are multiple ways to factor. We've talked about this last week or the week before and the week before. You can use the X method, guess and check, box method, whatever works best for you. I'm not going to require that you do it one way. What matters to me is that you understand how to factor. Since our leading coefficient is a 1, I'm going to focus on how to multiply to the 8 and add to the 2. And in doing so, I get x plus 3 still. Remember, it's our original factor. It can't go away. Times x plus 4 and x minus 2. So this is our given cubic in factored form. Yay! And then our roots, our x-intercepts are negative 3, negative 4, and 2. And what's their multiplicities? Think about the graph. If we were to sketch this, it's all coming together. If we were to sketch this, 1, 2, 1, 2, 3, 4. Yes, you should be sketching this with me on your paper. So we have negative 4, negative 3, and 2. They all have a multiplicity of 1. So it's going to cut through the x-axis at those locations. Sorry. And then our leading coefficient was positive. So that means we're going to go down to up because it is an odd degreed function. So we cut through, and then cut through. Nice job, everyone. Okay, I've got one more example for you. We'll call this example 1 for task 4 continued. Isn't it neat how it all comes together? I love it. Now we know, multiplicities, all these factors that we found come just once. It's kind of cool. Okay, so here's our second function of x. It is 3x to the 4th. And those of you that are thinking, Patterson, this isn't cool, don't lie to yourself. It is cool. Minus 32x squared minus 36x plus 45. Okay, something I'm noticing already is that there aren't any holes. We have 4, 3, 2, 1, 0, so we don't need any placeholders. And then we've got two factors, x minus 3 and x plus 3 are factors. So that means we know we're going to have roots of 3 and negative 3. All right, now our goal is to find it in complete factored form. It's a quartic, which means there are 4 x-intercepts. Real complex, we don't know yet. And I'm going to take the first factor and divide it out. Now there's a couple of options. We could divide it out at the same time if you would like. You could do it individually. Wait, what? The same time? Yes. If we multiply these together, we end up with x squared minus 9. You can use that as your divisor, but be careful because there isn't that linear term inside. So you'd have to take x squared plus 0x minus 9 to divide it out. You can do that if you'd like to do that right now on your own time and then check your answer with mine. Please do it. It might be a little bit longer way, but I'm going to take the original, oh, not in red. I'm going to take the original function, so 3x to the 4th plus 4x cubed minus 32x squared minus 36x plus 45. And I'm going to divide it by the first factor of x minus 3. Now we're told it's a factor, so it should work out. Okay, staying consistent with what I've done before, I'm going to take 3x to the 4th and divide it by x, giving us 3x cubed. That goes up top. Then we multiply through by every term in the divisor, so we get 3x to the 4th minus 9x cubed. What do? Change the signs. Okay, so those first terms are going to cancel. Perfect. We get 13x cubed, and we bring down the negative 32x squared. Again, we're going to take that first term and divide it. So we end up with 13x cubed divided by x, giving us 13x squared, and that goes up top. And then we multiply through. So we get 13x cubed minus 39x squared. And then we change the signs. Yay! Okay, so what I'm going to ask at this point is that you pause the video and you divide the rest of this through. Then come back and we'll see how you did. Okay, hopefully you found that if we take x minus 3 and divide it out, we end up with 3x cubed plus 13x squared plus 7x minus 15. Now, if you use the product of the two factors, just hang in there. Okay, so the next thing we got to do, since we already factored out x minus 3, is we need to take the other factor of x plus 3. We're going to take now x plus 3 and divide it out of the remaining cubic, okay? Because our whole goal is to break down the given quartic and see what its 4 factors are, real or complex. Remember, complex are the possible imaginary. We haven't seen those yet, but they could exist. Okay, so again, I'm going to ask that you pause the video, do this on your own, and then come back and check. So I'll see you in a sec. All right, here we are. So now, whether you decided to divide by the trinomial or take the little bit longer route with me, we should all be at the same place. So we get x minus 3 and x plus 3 as the given factors. Once we pulled them both out, we get 3x squared plus 4x minus 15. Now be careful. If you did choose to divide by the product of the two given factors, you need to make sure that when you factor everything out, you do write them out as the two factors of the product. I hope that makes sense. Okay, so now 3x squared plus 4x minus 15, we have to see if these are factorable. So I'm going to use the x method just because that's my preference. So I need to try to multiply to negative 45 and add to 4. This is a times c and then the b value. So can we multiply to negative 45 and add to 4? Sure can. We can take 9 times negative 5. Now let's say that, oh man, it wasn't factorable. What could we do then? How could we find the roots, the factors? at that point, we might have to use the quadratic formula. So know that that's always an option. Okay, factoring out still, we get 3x squared plus 9x minus 5x minus 15. Some of you that are watching the video that are thinking, I'm sorry, quadratic formula, what? Don't worry, we are not done with this. This is just to get you practicing, and then on Monday, we'll build off of it and do a little bit more, okay? So what I did is I grouped the first two terms, grouped the last two, and then I pulled out their GCFs, their greatest common factors. We did a bunch of this the other day. All right, here we go, my friends. So now our final factored form is x minus 3 times x plus 3 times x plus 3 times 3x minus 5. Can you, because I know this question is going to come up, but can't we write it as x plus 3 squared? Yeah, absolutely. They are exactly the same thing. So here's our factored forms. Our roots, we have x equals 3, negative 3, and 5/3. Just set each factor equal to 0 to solve to find the roots. They're our x-intercepts. Multiplicities, we have a multiplicity of 1 for 3 because that factor occurs once. X plus 3 occurs twice. 5/3 occurs once. So if we were to sketch, because that's ultimately where all this is going, all of this is related. 1, 2, 3. 1, 2, 3. All right. Let's use this fantastic color. We've got 3 and negative 3, and then 5/3 is about 1 2/3, so we'll go right about here. It is an even degreed function. There are 4 roots. It is a quartic. The leading coefficient, pardon me, is isn't even. What? Is positive, right? Going back here. 4 positive. So therefore, our end behavior is going to be the same. It's going to be up and up. I'm going to cut through. No, I'm not. I'm going to bounce off at negative 3 because it's a multiplicity of 2. However, I cut through the other 2. How high up, how low you go, it doesn't matter. This is a sketch. And there it is. Right on. Look at you. Nice job, everybody. Okay, so in your groups, I've got 3 examples that I want you to do just this. Work together at your tables. Sorry, no whiteboards today. Work together at your tables and factor out the given factors. See if you can find the multiplicities, the sketch, the end behavior, all that good stuff. And I'll see y'all on Monday. Have a great day.